Hello, my name is Ian Watson, and I'm the Executive Director of the American Membrane Technology Association, fondly referred to as AMTA. This is a continuation of our chats with the pioneers, in which we are trying to record for posterity, or maybe longer, the efforts of the early pioneers in the development of membrane technology. AMTA is a technical association that advocates the use of membrane technology for water treatment, ranging from wastewater reclamation and reuse to seawater desalination. The heart of the technology is the membrane. About 2.5 years ago, the board of directors of AMTA decided that we should make an effort to interview as many of the early pioneers in the development of this technology, not only the membrane, but also the membrane systems that came along with it, as a way of preserving the history of this technology. The roots of this technology are in the United States, and specifically in Southern California. And many of the people who worked in the early days live in and around the San Diego area. AMTA's intent is to post segments of these interviews or chats on our website so that the upcoming generation of engineers and scientists understand what went into the development of this technology and its use throughout the world today. Under the gun today are 4 gentlemen, starting on my immediate left: Jim Beckman, Paul Laverty, Harbans Kohli, and Peter Lange. I'll start with Peter. Can you tell us a little bit about your background in desalination and reverse osmosis?
Okay, it can go far back.
Go as far back as you like.
I would say it started really in '73 when I made a career decision because it was interesting to get into seawater. And there was some chance back in Germany, that's where I'm from. And I'm here in the United States since the early '79. Seawater desalination at that time was distillation. But the same year, there was an interesting development, which was DuPont's B10 membrane was sort of introduced to the market. That's when I sort of followed membrane technology and reverse osmosis from the other side of the Atlantic. And then Constellations gave me the opportunity to come to the United States and directly to one of the, at that time, sort of leading RO membrane manufacturers, Envirogenics Systems Company. So that was the beginning. During that time, there were several projects in the Middle East where Envirogenics was the membrane systems supplier, and I, on the other side, was helping to market and technically sell it to some places in the Middle East. There are 2 projects during that time, which were first of all seawater, but at Envirogenics we did not have a seawater membrane. So it was the old-fashioned technology which in the late '70s was still applied in competition to the B10 projects. 2-stage RO in Abu Dhabi and Dubai. These were all small systems, of course, because the large desalination systems still at that time went to distillation, MSF, etc. And since '79 with Envirogenics, I was involved in a lot of no, not local. Local comes later, but Florida projects for brackish water. That was the bread and butter business for RO membrane manufacturers who did spiral wound. Always still in competition to B9, but most of the Florida plants went so-called spiral wound technology, which now is still the prevailing, I guess, membrane configuration worldwide. The old, but they were actually the pioneers, in my opinion, B9 and B10, as the hollow fiber membranes spearheading the technology. But I think the competition between the spiral wound manufacturers and, let's say, probably the ease to make flat sheet membrane and develop them was the main criteria for spiral to really come out ahead. And somehow I think it has something to compare eventually with some other developments during the 70s and 80s, which where Sony tried to find a way for their special tape recorder, but VHS ultimately made it. So one technology nearly died, but came back in other form probably 10 years later for most of the other membranes besides RO, for MF and ultrafiltration, because those large systems are all non-spiral. I think, I should give it to somebody else to tell a little more, because if you come back to me, then we'll go into the time I was with Envirogenics following to hydronautics.
Okay, Harbans? When did you first get into water treatment?
Well, that was back in India. My first job was at a power plant, running water treatment system for about 2-3 years. It was ion exchange system mainly for boiler feed. And after that, I worked in hypochlorite manufacturing, sulfuric acid manufacturing for a few years. I went to Iran, and that company was a licensee of Kohli. We were selling small RO systems. And then we became sort of a, we can call it a licensee, but it was more like an arrangement with Portals Group. At that time, PCI, Patson Candy International, permuted Bobby, and PCI's RO division, which was at Laverty. We were representing them in Iran. That's how I got into the water treatment system. In 1979, after the revolution, I came to United States. Maybe 3-4 months or around that time, I worked for Kohli dealer. That was my first job. Then came an offer from Peter Lange. He's the one who brought me into really RO business. That was the first job, real job I got. And now I'm still suffering from that. Never recovered or covered out of RO business. So in 1980, I think it was February, when I came to Envirogenics. And Peter thought that he had enough of me, and he left. He went to hydronautics.
Like immediately?
He tolerated a few more months.
I guess I gave it a try. No, he was good. He was great. Mm-hmm. No, you were great.
A few months, maybe a year or so. When did you leave?
Early 81.
So it was 1 year, sort of.
1 year.
And the new guy came, he was a Brit, Bill Finley. He came from Ajax, and he was a process guy, and he sort of taught me how to go through hand calculations element by element. No computers at that time. The first computer we got had 10 megabyte hard drive, and it was a big deal. Only, few people were allowed to access that. Before that, we were connected to control data, and we were feeding data and getting output, and it was a more complicated process. But all the calculations were done by hand, element by element. My first job was as a project engineer under Peter. Then they gave me additional responsibilities, which included element testing, process development, became manager of membrane processes there, and then sales support also. Very interesting things happened during that course, and we can go through that later. So in 1988, I went to Stone & Webster, worked for a few years there.
And moved to Florida.
Moved to Florida, yeah. And one day, Jerry Alexander from LA Water came. He took me out for dinner. He said, "Harbans, what do you think of coming back?" I said, "Make me an offer." He made me an offer. I went home, told my wife that we have an opportunity to go back. And they said, "We are packing and going." They did not ask me what salary you're going to get, where is the job, nothing, no question. We are just going. So I didn't have much options. We came back and started with LA Water. I worked there through 1996. When in between it got acquired by Portals and Thames, and eventually got sold part of it to US Filter. I worked for a few years at US Filter, then Membrane Systems. And since I think 2000, I have been with them, so almost 12 years. The last job at LA Water was Vice President Marketing and Sales, which included project management as well as field service and all that. All 3-4 groups were under sales.
And one of your tasks there was to learn AutoCAD.
Well,
But that's another story.
That challenge is still there.
That's another story.
I have the books, I have the AutoCAD, but I don't really work on AutoCAD.
Now, Paul, I found out something about you that I did not know when we interviewed Jim Logier and Bob Bergman in Glendale this past spring. That you actually started many years ago on the original Yuma pilot plant.
Mm-hmm.
I did not know that. In all the years I've known you, I did not know that.
That was some of my later work in the Yuma plant. I started at the West Coast Desalting Test Facility in Chula Vista in 1970. And I was attending University of San Diego, and it was a summer job. And Burns and Rowe was operating the facility. And there was the Claire Engel plant. It was a 50 MGD pilot, a pilot for a 50 MGD installation up in Huntington Beach. There was going to be a power plant, the nuclear power plant, and the plan originally was to have 2 reactors for strictly power generation, and then a back pressure turbine that would produce steam for thermal desalting, MSF.
That was the unit that was packed up and shipped to Guantanamo Bay.
Actually, the Point Loma unit was pulled out when the water was cut off in Guantanamo, and Burns and Rowe took the responsibility for commissioning a power plant with extraction steam for initially the Point Loma unit, and then there were 2 units in that were scheduled to be delivered to the Virgin Islands, to St. Thomas. Harvey Aluminum, I believe it was the customer for 2 units, and those 2 units were also diverted to Cuba. So there was quite a desalting capacity installed in a very short time interval after the water was cut off. In the interim, water was just being trucked in from Puerto Rico, I believe, or not. Excuse me, not trucked in, shipped in.
And then you went from there to Yuma?
Yes, basically I was in Guantanamo Bay, Cuba, after I did my stint at Chula Vista at the OSW originally desalting test facility. I did a little over 3 years in Guantanamo Bay, Cuba with Burns and Rowe before I came back to Yuma with Burns and Rowe. And Burns and Rowe operated the facility while I was there from January of '75 through mid-'77 when Planning Research Corporation took that contract.
And then you went to work for PRC.
Yes, the contract changed hands, and PRC took over from mid-'77 through the end of 1982.
And when did you go to Hydronautics?
It was Mr. Jim Bartlett and Steve Bartlett had test units there at the Yuma test facility, and they offered me a position whenever things wrapped up there, and so I immediately went to San Diego. FU. Actually, I went to San Diego first and was working with Seymour Kremen for a year or so before I eventually moved up to Santa Barbara.
Mm-hmm. Mm-hmm.
Very good.
Now, Jim, you were at Roger and Fluid Systems a long time.
Yes.
Probably one of the longest stints of anybody we've interviewed from there.
Well, I saw Bob.
Which either means that you didn't see the writing on the wall.
I don't know what
You're a
happened.
perpetual optimist.
Slow learner, I guess. But anyway, yeah, I saw Bob Riley out earlier, and he goes way back. I started at, in those days it was ROGA, R-O-G-A, Reverse Osmosis General Atomic, and 1968. December of 1968, and I'd just gotten out of the Navy, Vietnam, and I earlier had been at San Diego State. I have a degree in biology, and I was just looking for a job and sort of walking around different aircraft facilities and in San Diego, and stumbled onto the Harbor Drive location. And went in the lobby, and I said, "What do you guys do here?" And the lady, the secretary, the office lady said, "Well, we have this process called reverse osmosis." I'd never heard of what it was, and she gave me a brochure. And I went home and studied it on the weekend. Then I came back, and I managed to get an interview with Seymour Kremen, and also that same day talked to Al Riedinger and Jerry Foreman, and they ended up making me an offer. And it was kind of neat because Seymour said to me, he says, "You know, Jim, if you come to work right away here at the end of the month here in December of '68, on the 26th of December, you'll get credit for the full year of working at General Atomic," which was a good deal. So he managed to get me in. I had to go through personnel up at the main plant, but in those days, even though we were part of General Atomic, we were separate. It was run by, our boss in those days was Ted Larson, and Seymour was in charge of R&D, and Izzy Nussbaum was there, and Jerry Foreman, and many people, Tom Wolfe. Anyway, so I started working there, and I was a research assistant, and I was paid $650 a month. In those days, that was pretty good money for a college graduate, and then that was in December. And then in January or February of 1969, they hired Randy Truby at the same pay scale, and we were both called research assistants. And it's kind of interesting because we both went to San Diego State. We both have degrees in biology. I stayed and worked with Seymour and everybody in R&D there I worked at that company. Had different names, the UOP, Gulf, Shell, then it ended up being Coke, membranes. But anyway, it was 33 years that I was involved with R&D Just pretty much all in San Diego. I did do a little bit of travel a few times, but mostly in-house problems, and stayed right there and worked with pretty much. I have friends at all the desalting places across the United States. I know at least one or two people who got their start at Roga, and I wanted to mention that when I started working there in 1968, it was cellulose diacetate membrane, and we were just getting it on the fabric. They just trying to cast it directly on the fabric. That was one of the main projects that I was working on, and we figured out how to do that. But in those days, the membranes. A good membrane, a 4-inch element, that was about all we could make, and very few of them made it through. There was a lot of leakers, but the good elements in those days made about 95% rejection. A good element, maybe 96. And the kicker was we were running at 400 to 600 psi, not the 150 that is being used today. And we were making maybe 12 GFD on brackish water at those conditions. And of course, later on in the 70s, we started getting involved with the thin film and the membranes they have now. It's just a world. I would never have dreamed that you could make a membrane that would make 25 to 30 GFD at 99+% rejection at 100 pounds. That's blew my mind because all the struggles that we had trying to make something work. And the thin film membrane, of course, has changed the technology completely. That you could make a super thin membrane and have it make a lot of water at really good rejection and low pressure.
Actually, on that, I have a comment. Back in the 80s, and Viogenic started to make thin film composite membrane too. And the first batch of membrane they produced could not tolerate chlorine. And they said, well, this is not going to get anywhere. Everybody was so much against it, sitting in a meeting, they said, this is a waste of money and this and that, and let's drop the project altogether. And now look at what happened.
Oh, yeah.
It has changed the whole RO industry.
That's right.
And also, to your other point, 4-inch elements. Roga still have a picture of initial element they rolled, which is only 2.5 inch with netting and all that.
Right.
And Viogenics also similarly could not make more than 4-inch size element. But they came up, I think Peter would remember more than I do because I saw the actual facility, RAK in Dubai. They could make 8-inch, so they put 5 4-inch elements into one vessel.
Oh, yes.
I was going to ask you about that.
That's one of the, because if you switch 30 years later, something similar in 8-inch exists.
Yes,
Right.
that's right.
So,
Somebody tried.
Okay. Yeah, it was a very large diameter steel tube with an arrangement of 7 4-inch elements. Okay, 1 center, 6 around. It was introduced at a facility in Ras Al Khaimah
Yeah.
about 1979. The project, okay, it was the first one where we had 6 elements in a row and this nice arrangement for a 4.5 MGD system. That was a pretty darn large system. Complete.
At that time, yeah.
For that time, it was one of the largest RO systems. Why? Because at that time, there was no equipment available and no full knowledge available to make consistently good CA membranes in 8-inch. But that system lasted a few years. I've been there twice and have seen what you could do better with regards to this arrangement, but it never took off afterwards. So when I joined in '79, we basically dropped it and put all the effort in 81. We had practically 8-inch rolling facilities established. And if you would consider, okay, we need a system with 800 8-inch elements, that was practically probably 3/4 of a year production capability, because everything was made by hand.
That's right.
Right.
Yeah.
Everything was trimmed by hand.
Yeah.
It was a messy operation around these making elements.
You can't believe what it was like when Nito Danko first saw the spiral membrane element production facility for hydronautics.
Oh, yeah.
They were just, they couldn't believe that this could be commercially viable.
Yeah.
They just couldn't believe it. And then when I visited
Well, that-
their facility, I saw why they were
Yeah,
so shocked.
the same trip, and Mike Humphreys was with me. The same trip, we visited Hydronautics, and they had constructed their casting machine out of plywood. And the applicator was a series of sponges they'd bought from the Five and Dime, I think. I said, you got to be kidding me. These guys.
Yeah, I think at Roga, down on Harbor Drive, we were pretty embarrassed to even have people come to look at our facility because it was so embarrassing. But in those days, when we first started making, well, even after we got it going, the thin film, with the applying the amide and everything after you made the polysulfone. Making the polysulfone was pretty well straightforward. Putting the two coats on the thin film membrane. We used the two best tools that we had available was a turkey baster for sucking the bubbles off the edge of the trough so that they wouldn't wind up making pinholes on the final membrane. And then we would get foldovers as we were pulling it through on the rollers. The membrane would fold over because it was being heated as it was moving along on all the rollers to dry it out. And the fix there was to tongue depressor, which you laid on the fabric and stapled it on, so that when it came over the roller, it would stay flat. It wouldn't fold over. So that was was a couple of tricks of the trade that we used down at Fluid Systems in those days.
It boggled my mind.
Mm-hmm. But when Peter was talking about it being a kind of a handmade operation, some of the first membranes that went on that first big seawater job that Bob Riley made, the thin film, a lot of that was just made at Rose Canyon and then taken down to Harbor Drive, and it was this van. You had a van and you would shove the membrane in, and it was really pretty much everything was handmade. And you would hope that you got a good roll of either polysulfone or the completed membrane, and a lot of testing and a lot of scrap. It was
a lot of scrap.
It was not. Yeah. It was not like it's made today. I looked at Torre's plant recently, and I was amazed at how smooth things work.
Even on CA membrane, I recall the scrap rate was quite high, almost 8 to 10%, and then it slowly dropped to 5, 4, and consistency of the membrane was always in question.
Very seasonal.
Yeah,
very seasonal.
Seasonal, and actually, people would always blame it was the humidity, it is this and that.
Yeah.
And to that point, I think I remember we were having a meeting with Bob Tidwell once, and it was, I think, Aransas County job, which eventually Carl Hickman got involved also. We tested the unit on city water in El Monte, and it did not perform. It was certain that it will not meet the capacities and qualities we have guaranteed to the county. We tested, and Bob said, shut it down, flush it, we'll try it tomorrow morning. Okay. Next day it's the same thing. Then they said, well, there is something in this water which is causing this. Let us ship it anyway. So we shipped the unit, it didn't perform, and we were into a lawsuit again.
Ooh.
So, that was the state at that time. And one time, Peter was explaining to Bob Till, and we were all in a conference room explaining the problems we had at Pine Island. And he was giving all his, technical explanation of the flux decline, and a lot of those things were very new to me. And he was explaining, and after we came out, Peter said, "What an interesting meeting. We are discussing important things, and Bob Tidball was dozing." He was the VP technical, and he was a really heavy, healthy guy, and one can understand that. But
I recall very early, practically the first year, I went to Key Largo. They had a nice Roga plant, but it didn't last. It didn't last, and the real problem that comes into the picture comes then a guy named Dale Rowe. I don't know where he is. He's out of South Florida in Key West. So went there, looked at it, fouling, new membranes in, fouling, cleaning, didn't work, CA membranes, that's for 79 or so.
Yeah.
Then looked at, let's say the record keeping was not that great at that time. Nothing printed out on routine.
handful
Every
log
hour
sheets.
you measured the
And you had to
TDS.
rely on the operator's log.
Yeah. What happened at Key Largo had nothing to do with RO. The only thing is, those poor guys at Roga, okay, they got it on their nose because they were not fast enough. At that time, we had a guy there who wanted to sell our membranes. It was a 4-inch membrane system out down there. Okay, we have to solve the problem. We have the better membrane. I said, yes, we can, but we have to solve the problem differently. Because what they didn't know is they had 2 strata of aquifers. They took it out from the lower portion. But it was very obvious because when you looked at their cartridge filters, okay, full of sulfur. So if you have this stuff already coming out of the ground, and that stuff is hard to remove from those membranes at that time. It has nothing to do with the membrane. Okay, that's when really, I have to say, that's where I continued, I think, the most in looking at what are the chemical conditions of the different kinds of waters.
Yeah.
Hey, in any other place, this 5 or 10 ppm of H2S in the groundwater didn't cause a problem. Why should it do there? Huh? And they found out, Dale was involved at that because I said, look at that. They were, I think, supervising the operation there. Look at that and find out if this is 3,300 ppm water, this was about 1,800 ppm water. Okay, look at what you get. And there was around the well, the 3 wells or so, there was some connection between the 2 aquifers, but that upper one had about 3 or 4 ppm of oxygen. Well, you had it.
Yep.
Okay, so there was, you couldn't do anything with RO there, you had to solve that kind of a problem.
Yep.
Okay, so that's also the times when some of these wells got cemented and had to be treated with hydrochloric acid, and that caused sometimes problem with the materials. So many, at the very beginning, many of the bad rap, I would say, which RO got, was that people did not really combine really water chemistry and design, engineering of components.
Yeah, that's right.
And that's why I said,
Well, that's what happened.
I liked it.
That's what happened in Sanibel. See, when the ED plant was built,
Yeah.
all those wells were steel cased. It didn't matter there because you aerated the water first, and then you
Yeah.
went through a
Yeah.
filter system, and then through the ED. When we started the well CRO plant, Tom Missimer, who had just started his consulting business at that time, said, it'd be much better if you made the wells of plastic. No, talk to the old well drillers.
No.
Plastic?
Yeah.
What's wrong with steel? Well, steel, is attacked by the water. Oh, no. I can get you as much water you want, any quality you want with a steel well.
And they've been doing it for decades,
they've been doing it for
but they weren't
decades.
supplying membrane.
That's
Yeah,
right.
That's
yeah.
right.
That's right.
You see, there are a few points I want to mention. One is, years ago, everybody was pushing the envelope in terms of flux, pressures, you name it. Nobody was really conservative enough to think that, lower flux is better, lower pressures are better. Everybody was pushing the envelope. That's why it got a bad rap.
Well, one of the reasons was because the membranes were so expensive.
They were expensive.
We paid
yeah.
for the Sanibel plant. Jim Bartlett wanted $1,400 an element
8.5 inch.
for 8.5-inch replacements.
Yeah, I understand that, but I think the point is the chemistry, the process, what I am talking about flux, they were not fully understood.
Right.
People did not realize the implications of what they are doing, including me, I'm not saying. So we were almost blind to that. And to earlier comment by Peter, DuPont, I think, is the pioneer in this. They are the ones who develop the manuals and all. They are the really, I think, backbone of the RO industry.
Yeah.
They are not in the picture these days, but they were. But if we look back, I still believe that hollow fiber being able to provide a lot more membrane area, and now that we have hollow fiber UF and all that, I think it has a place now. You could go high flux. High flux there is only 2-3 GFD.
Right.
You can go high flux, lot of area, and with a smaller footprint, you could do B9s today.
Well, that's true, but don't you think that that some of the same issues that always existed, like distribution through the bundle and that kind of thing, still exist?
So, yeah. Yeah,
And that was really one of the problems. We found a lot of permeators in Florida that had sulfur in them, that shouldn't have had sulfur in them, but they had sulfur in them. Where it came from, we don't know.
Yeah.
But that blocked large chunks of the bundle. So you got sort of
some dead areas. You
maldistribution.
think.
Yeah.
That's right.
Could be some
right.
dead spots. And
Why
all
did
that, but
Envirogenics go out of the membrane manufacturing business?
Well, I think they could not compete. They were not able to produce the quality of product which was available at that time. And the market got very competitive. It was cheaper to buy from fluid systems than to manufacture on their own. And then also, I think a lot of money was invested in gas separation. And it didn't go anywhere, although it could have. And then money was pulled out, no more funding available, so they thought it's cheaper to buy from hydronautics and fluid system than to manufacture their own. One of the main reasons was that they couldn't make much progress. R&D was not properly funded. And it seems to me, looking back,
At Envirogenics from the ownership. When the ownership changed, the main reason for it was to get hold of the old Aerojet BLH patent for long tube distillation. And that to have that to go out and quote through Sojix large MSF plants. That was the main reason for buying into it when Aerojet sold this envirogenics portion of the whole thing. It was also as a split of, if you are part of a huge organization, and now this this small portion has to be run a little different than through three big binders of standard operating procedures, which everybody who was working for a large operation could, but those people who had a little, let's say, imagination, spirit, etc., bring something in. If you had to learn that, you had to stay there for 3 years at first to follow exactly what was going on. So the interest of the company was purely in MSF and was pushed for a while, for about 3 years, to the point, okay, make us competitive in RO. And there was this case of a seawater-like membrane, which was developed in late 78, which performed spectacular. 4-inch tests on 4 different facilities. The only problem was, and that's, we looked over to Roger and said, how nice they have it. This membrane disintegrated within about 700 hours. For the first 2 months, stable production, wonderful. And then nobody actually went after it. That was a moment when my old friend Toozle said, okay, we buy a new casting machine, we'll have it made at that time for about $250,000. And when that one was ready, in all cases, this kind of membrane failed badly. So do you want to manufacture that? So they had to go back to square one and find out what. And it's one of these 3 components, chemical components, which was developed up there where finally Filmtech came out of. What's it?
North Star Research.
North Star Research, exactly. Okay, that was one direction. If you go back to these, you'll find that, and as I said, 3 different places on seawater, on brackish water, and after 750 hours, in pilot plants, of course, 4-element long vessel being tested, under ideal conditions like CA membranes would be, just to find out. They never could make it back, and that's when they lost a lot of. But now they had the machine for casting, and then things changed to go. Yeah, there came 2 or 3 R&D contracts for gas separation, based on casting membranes. You could use that machine, and then there were other things.
Yeah, actually,
to the demise of
you know better than I do, but seems to me, in the mid-80s, Sojix basically decided to let it die because they didn't want to invest anymore. In fact, they were, funding envirogenics on day-to-day basis, basically. And the commitment was not there. One of the other interesting things I want to mention, during Peter's time, we sold a system to Alba.
Alba, yeah.
Yeah, 2-pass system.
Aluminum.
And we did the hand calculations and all that, and we sold the system. We can meet the quality. Then we sell it. Peter leaves, comes Bill Finley. He asked me, go through all these calculations again and blah, blah, blah. We did it, and I said, well, we may not be able to meet the quality we have promised. He took it and he says, yeah, it makes sense. So what do we decide? Now we call it snake oil. We said we'll take the CA membrane, treat it with the colloid, raise the rejection, and that will do the trick. So, okay, I was given the responsibility to do that. So we started to do element by element. We were injecting colloid, and when 95% reaches 97.5, we cut the colloid out, flush it out, and we did all that, and everybody was so happy that, we'll be okay. We sent all those elements there. Now, we can't meet the capacity.
Little trade-off.
No, we knew it will drop the flux, but it dropped so much, the quality was almost twice as good as they wanted, and the flux was lower. So they said, let's think, what can we do? And they came up with an idea that let us treat it with high pH, and colloid will go into solution, and that means the rejection will go a little lower, the flux will improve.
Yeah.
We tried for 1 week. Colloid would not get off the membrane with high pH 10. It's a CA membrane.
How high can you go?
Nothing happened.
I can relate a little bit of that technology about, in those days it was called sizing. And what happened was we bought at Fluids at Roga in those days, we were buying the membrane fabric from Texlon, and they were sending us this style called 715, which was their standard fabric that we liked. We tested a whole bunch of them, and we liked that one. It had the right permeability, and the membrane seemed to stick to it pretty well, and we were very happy with it. Every once in a while we got these membranes and we couldn't figure out why they were such higher rejection than our standard membrane. Lower flow but higher rejection. And we did a little investigation, and it turned out that they occasionally would send us this style 716 instead of 715. And we said, well, what's that? And he said, oh, well, that's some of our customers that were selling this fabric. They're not in the water business, but we're making all this fabric, this
identical.
And it has this sizing material on it. And that was what started this whole thing about that kind of a membrane. And we, Jerry Foreman and Seymour, right away filed a patent and got a patent on that. Yeah. So anyway, it turns out that we, through working with Texlon people, found out what the chemical was. What is it? How are you making this 716 with the so-called sizing material on it? And they said, well, that's a product that we buy from Colloids, and it's called Colloids 189.
Yeah.
And so we figured out, well, why don't we just get the standard membrane without the material already attached, already sizing, and do our own. And that's sort of how we learned how to actually make membranes and then treat it with the colloid, either at Harbor Drive or out at Scripps Ranch, or sell it as a product. And that was kind of how, and then the industry, and that was a very good product, and it stood up amazingly well. You could put it on out in the field, or you could sell elements with it already on, and it took a long time before you started seeing
that actually helped us to get some seawater systems, because we could treat the first stage, bring it up to 98 point, something like that, and have a second pass which is 95% or 96%.
Yeah.
So we did.
So when did you go to Hydronautics, Peter?
Early in 81.
And you were already there?
No, I started in January of '83.
And I went there in 83 also.
Yeah, I think in '83
Yeah,
also. Mike
that's
Humphreys was there when I got there. He got there in '82 then.
No. Mike Humphreys was still in Sanibel. He joined like a year or two later.
Okay.
Yeah, that's right. Yeah, that was when we awarded that contract in Sanibel to Hydronautics, it created all kinds of chaos.
Yeah.
Yeah.
Who are these
But
guys?
In the meantime, you have to see, Paul was at Yuma and looking at those proof test units. Yeah, 2 companies had the job.
Right.
Okay, sometime in the near future, within the next few years, to supply some membranes. 7.5 inch, no, 8.5.
8.5.
8.5
it's
inch.
8,
And
Eight and a half.
and 12 inch.
that's right.
Okay. So
That's right. That was
and
one we made.
when he was saying, okay, we had to calculate membrane by membrane. That brings me back to Yuma, because that was the point when the 6-element long pressure vessels at Yuma proved test facility, they proved that they could make quality, but because of some uncertainty about a stuff called 189, which of course nobody actually said for my higher reaction CA membranes we are using. No. So in the whole in the industry with other companies, you say, okay, this is not type or slime type or that was the. But everybody was then referring to, DuPont has something which they use for their B9s.
Yeah,
as
yeah.
well.
That was
It's
tannic
completely
acid.
different.
Yeah, that was PTA,
Okay.
PTB.
Yeah, that's right.
Oh, okay, that was a.
And that came off.
Yeah.
So you had to
Yeah.
recoat that every
Yeah, that
time you
was-
cleaned the things.
Well, actually, that's what the DuPont considered as an advantage, that you could clean it and put it back,
Back.
and if rejection goes bad, you can put it back.
Yeah.
But colloid was a different animal altogether.
So Yuma needed, and we couldn't make the capacity. We had only 25% of the total job. Okay. So invention by Jim Bartlett. Okay. Can we make it 7-element long? Then we gain something like 1450. Exactly something like that. What was missing in
Area.
capacity.
Yeah.
That's when 7-element long pressure vessels
right.
started.
That's
Because
right.
I don't think that you had them at that time, but we had to do them. And of course, the most difficult part was, hey, there is no 7-element long, what is that, 350 inches or so, mandrel. We had to pay for that.
Well, that,
Somehow Jim Bartlett found a way.
but we
to-
didn't have, we had 6-element vessels at Sanibel.
Yeah, yeah.
But we had 7-element in Cape Coral.
Yeah, yeah. That was when we decided that. So you were not there, I think, that moment. Steve Bartlett and I went through this whole calculation. I mean, the Bureau had accumulated so much data. You went through this and you saw, oh gosh, look what they have, computer stuff, etc.
Data acquisition.
Okay, so we did this by hand.
No,
Then we established the 7-element long vessel and actually got some made and total switch, and on that basis we could continue to get the Yuma job
Right.
into the
yeah, back in the
application.
in 80s at Envirogenics, we got 2 jobs, Duba and Hakel. Seawater, 4,400 and 6,600 cubic meters per day. They opened the bid for 6,600 cubic meters day first, and we found our price was too low. And people who were, Bob Kadaj and company, they were there, and they said, well, we are low, and 4,400 is low. So they changed the price on 4,400 higher than 6,600 cubic meters. When Sodis opened the second bid, said, how could that be? Well, that's the way it is. And then they put a caveat that we'll take the first order only if you give us the second one also. And we got that order, but we changed the membranes to Thiobo, and I was given the charge to test that membrane at our facility, and we could not get stable performance. We ran, and it wouldn't do it. So we collected all the data, sent it to them. They said, Thiobo said, we want to discuss it. So I went there with Haney, and we spent a few days and gave them all the calculations, and they came back, well, really, we should lower the recovery. And they, agreed to change the design, lower the recovery. It was not stable. And that's when they learned about betas and all that. That is, concentration polarization is making it unstable and it's not converging.
Yeah, that was.
At that time, there's some company who was nearly not mentioned at all. That was Torrey.
Mm-hmm.
And
Right.
Torrey got their step into one of the water factory 20
Orange County, yeah.
system. And everybody was following up that. And you were there.
Now,
And we had to take, that was the first one.
but the flow
Right.
path was
They
like
had a
this?
different,
Because they had to avoid the
That's right, yeah.
right?
Right.
But
I remember
even,
that.
But even that did
Fed
not,
from the edge.
Right.
even that
From the
did
outer wrap.
not solve what they always found there. Okay, the rapid flux decline. Okay, cleaning, etc. So it did not perform better than the U.S. spirals. Okay,
Right.
then they came out with the replacement of 8-inch elements.
Mm-hmm.
And after their experience with some of these end caps, something.
Oh, yeah, that
nobody had
was
mentioned.
fluid systems,
Yeah.
pressure vessel design, yeah.
The metal- the metal,
the first,
yeah.
they had some blow off of end
Yeah,
caps. Okay,
Victolics.
we had them too, but we didn't tell them anybody.
Yeah.
In Marshmar, two of the end clamps came off and flew through. That is in Saudi Arabia on a brackish water system.
It happened at Envirogenics. We were testing a single element, and we all talked about that there was no seawater element, brackish element with simplex material and all that. We were testing at about 700 psi. The end cap flew. It went through the wall outside in the parking lot. It was that bad.
I think most interesting aspects of membrane development was that the fluid systems were so far ahead of everybody else.
Yeah.
But then all the guys started leaving. They're going to work for the competition. And in fact, you three guys competed with one another for
Oh, yes.
Virogenics, hydronautics, and fluid systems were competitors for at least a couple of years.
Many years.
Many
Many
years.
years. And
Yeah.
and you still talk to each other.
Yeah, well, I always like to I always like to say that since I've been in the business so long, and there were so many of us that started out that was like the school of RO
Yeah,
learning
that's right.
was at Roga Fluid Systems, and I have friends at pretty much all the companies, that are either they're still there or they recently retired or something. So
Right.
and you're right, it was extremely competitive. I can remember. Cadet and the work we were doing on thin film, and Riley, and they were they get it again. They jumped ahead a little further, or it was back and forth.
Right.
We all had in those days. We all had these OSW or EPA
Yeah,
contracts, and
funds over, yeah.
so information was shared, but it was friendly. It was not real ruthless. It was like congratulations, we'll get you next time. That kind of attitude, and I think that's. For me, it's been a fantastic career because of all
You
the
mentioned
people, the
we've been
friends.
competing for UNESA project. While Envirogenics was still manufacturing, we bought all membranes from fluid systems.
Mhm.
All elements were bought from fluid systems
Yeah.
for the entire project.
And then at Orange County, we had to buy at Hydronautics the pressure vessels from the other guys. The ones. That was because the pressure vessels for the new remembrane of 5 or 6 trains had to be replaced. No?
Right.
That's Paul has a lot of time spent there. But before that, there was a very strong Orange County consultant, strong-headed Orange County consultant, who insisted, or who accepted at that time, I think it was 84, 85 when this remember, that he didn't have a high respect for hydronautics people. Okay. And but he accepted somehow that we could bid as hydronautics, but somehow because he was located further south in Southern California and had closer connections to the other membrane vessel manufacturers, and he was not only convinced that those were the better ones, which they were. So that was when hydronautics put their membranes into what were you called at that time? Still ASI?
Advanced structure.
Advanced structure.
Yeah, okay, advanced structures.
Yeah.
And we went down there and made the arrangements, remember that? Okay, so, and then we had to compete hydronautics with ASI tubes against who?
Fluid systems.
Fluid systems.
And you won.
But you know, this whole job, I remember this too well because, first of all, Water Factory 21 in the 80s was the one address okay, for accumulated knowledge on RO. Let's put it that way.
Yeah.
And they had great people there.
Oh yeah.
The bid goes out for everything, including installation, etc. 803,000 against 808,000. Hydronautics was the lower bid against this. So that close, everything has been calculated. And okay, we got it. Paul knows too well whatever happens then. But it was for us. It was a prestige job, and I think you saw it the same way to compete against the original FRP pressure vessels. But I mean, they were so far ahead to anybody in the 80s. There's no comparison.
I have to wrap this up, but I'm going to ask you all a general question. Who else do you think? This is an ongoing series, as long as Doug and I are able to keep going. Who else should we be interviewing, in your opinions?
One of the R&D guy I remember at Envirogenics is C.W. Saltonstall. If he is available, I don't know.
Is he still alive?
I don't know.
But I was
don't
wondering
know.
as well.
I think I heard that Saltonstall died already. I'm not following up with that very much. So the best to find out on Envirogenics side who's still available, maybe Henny, because they are longer before me and longer.
Yeah, Henny used to.
And I think on hydronautics, you might have had already everybody and his brother on.
Well, we really haven't had very many people from hydronautics. Mainly because
they came from
other places. Right.
Yeah.
That's right. That's right.
Rick in there.
Rick was there.
Gary
Rick
Foreman.
was there. Right. But Paul, can you? I mean, we've done
Seymour.
Seymour's passed away.
The scope here is really reverse osmosis.
Yeah.
Yeah, I was going to
Well,
say.
it's membrane technology, but because of because of the fact that we're taking a historical perspective. I mean, it really is reverse osmosis.
It would be interesting to get somebody, for the Dow CA 250 membrane.
Hollow fiber, yeah.
Yeah.
Mid 70s.
That's right.
That would be interesting.
And we're going
Lynn
to-
Applegate. I don't know if he's still with us or
We're going to try and do DuPont here.
DuPont.
Harman would be then.
Yes. Herman, if we can find him.
If you extended it to ED, I would think Dave Aliano or
Yeah.
Dick Parent.
Yeah, those guys, and Ed Geishacker.
Yes.
Yeah.
Yes.
And Bill Katz is still alive, but he's not. He's in his 90s, I think, 95 or something like that. So,
Doug.
I mean, we've done most of the
Yeah,
fluid
that's what I was
systems
saying.
people, I
Doug has
think.
mentioned so many names that that when he contacted me that they'd either interviewed or they were planning on interviews.
Right.
I think as far as the Roga people, I think that you pretty much covered every. And as a matter of fact, I saw Bob and Merton out here
Yeah.
earlier, and Charlie Hall and Bob Play. And
Actually, Bill Finley did a lot of work at Ajax and then Babcock. I don't know. I think
took
he
a-
has gone back to the UK.
I took a train trip with Bill years ago in Japan,
Uh-huh.
and wasn't he Franz Breitling's stepson?
I don't know.
He was Joy
Bill
Breitling's son?
Whose son?
Joy Breitling.
No, I don't know. That I don't know.
Have you talked to Ashwin?
No, not yet.
Ashwin is.
That's it. I've got to wrap it up.
Okay.
Thanks very much.
thank you.
And, at the dinner tonight, if you can come up with any other thoughts, anecdotes, we're going to be recording it, and you can tell stories to your heart's content.
Great.
Good.
Thank you. Ian.
Thank
Okay?
you.
Thank you very much.
Interesting. Yes.
If Ron